voltage gain, and output impedance by using the exact model for different configurations. In the similar way, we have obtained the formulas for same like input impedance, current gain, voltage gain, and output admittance for by using the for different configurations by using the approximation model. So there are a little bit variation between the exact model and approximation formula. Approximation is the simplified formulas and exact is the full length formulas. Okay, so we have obtained we have derived the expression for all the parameters like input impedance, output impedance, voltage gain, and current gain. So in those cases, we have not consider the emitter resistance into account. We are not considered the emitter resistance into account. So now we are going to see the analysis of the C amplifier with emitter resistance. Okay, if you go through the circuit, the first one is nothing but a C amplifier circuit. The first one is it is a C amplifier circuit. Simply consisting of one transistor, NPN transistor. There is a load resistance or collector resistance RC. There is an emitter resistance and R1, R2. R1, R2 is for proper biasing, and there is a blocking capacitor and a coupling capacitor. So there is a VCC and the signal source and source resistance. Source signal and source resistance. This first circuit indicates the a simple C amplifier configuration with emitter resistor. Okay, simple C amplifier configuration with emitter resistor. Okay, now according to our design steps, we have redrawn the steps to obtain the small signal equivalent. So we have this is actually the C amplifier circuit with emitter resistance. Now we are going to draw the AC equivalent of C amplifier with the emitter resistance. So in this we are going to start with the complete circuit diagram. So this is the complete circuit diagram. After that, we are going to assume that all the capacitors are considered to be short circuit. So here we have a capacitor CC and CB. So we have considered these two capacitors are short circuited, means these are simply connected, shorted, and then we are also eliminate the DC also grounded, DC source. We are having a DC source. We are going to replace this DC power supply by short circuit or simply ground. By short circuit or simply ground. Yeah. So we are going to take we have taken this is DC voltage is short circuited, and then we have replaced this transistor with its equivalent hybrid model. Yeah. We have replaced the transistor with its equivalent to hybrid model. So this is the equivalent hybrid model HIE. HOE, HFP, and HRE. Okay, so these are the hybrid equivalent model of the transistor. The same circuit can be redrawn by using this hybrid equivalent model with emitter resistance. So here there is an emitter resistance. Yeah. So we have taken, this is the base terminal, this is the collector terminal, this is the emitter terminal. So in between base, emitter, and collector, we have replaced the transistor with its equivalent hybrid model. So we keep source resistance and source voltage as it is. We have taken the R1 and R2. R1, R2 for the proper biasing. Okay, this is a HIE, HRE, HFE, and HOE is the hybrid parameters of your transistor. And then there is a load or collector resistance. There is a load or collector resistance. Have you understand the circuit diagram? Hello? Hello?
Yes, sir.
Okay, na? And, simply we have taken the C amplifier circuit. This is the basic circuit for the C amplifier. So now we have applied the step-by-step procedure to get the hybrid equivalent, hybrid parameter model of the C amplifier with emitter resistance. So this is the simple amplifier circuit, C amplifier circuit with emitter resistance, and we have shorted the capacitors and shorted the DC voltage. Okay, DC supply, DC power supply is shorted and the capacitors are started. So we can after shorting this capacitor and DC voltage, we have redrawn this circuit. Okay, now we are going to replace this collector, base, and emitter terminal of the transistor like here, and then we have replaced the transistor by with its equivalent hybrid model, hybrid parameter model. Yeah. So because of this, the C amplifier, we have taken the hybrid model of this transistor. Okay. Now, if it is clear, then I'll go to the next one. So anybody other than A3?
Okay, sir.
Clear.
Clear? Have you drawn the
Yes, sir.
circuit? Oh, have you drawn this circuit or not? So please draw the
Yes, sir.
circuit. So this is a simple C amplifier. So there is a procedure to convert this C amplifier into its equivalent hybrid model. What is the first step means? Simply you have make the short circuit of the capacitors shorted. Capacitors are shorted. Okay. So we have two capacitors in the circuit, a blocking capacitor and coupling capacitor. These two capacitors are shorted. Okay. And then replace the DC power supply by short circuit. We have replaced this DC supply by the short circuit or simply grounded, and then we have replaced the transistor by with the hybrid equivalent hybrid parameter model. We have replaced the transistor with the hybrid model. The remaining things are we kept as it is. So source resistance and source voltage. There is a biasing resistance at R1 and R2. There is a load resistance or collector resistance, load or collector resistance. Okay. So same can redraw the hybrid model, hybrid parameter model of a C amplifier with the emitter resistance. We have taken the emitter resistance as it is in these from first circuit to second circuit and second circuit to third circuit. But earlier case we didn't consider this one. Okay, we have neglected this one. But we are going to consider this emitter resistance while analyzing the C amplifier. Okay, so that's why this analysis are simply known as the analysis of the C amplifier with the hybrid analysis of the C amplifier with emitter resistance RE. Okay. Now, since in a transistor C amplifier, the values of HRE, HOE are very small. Of course, we have considered in the approximate model, the value of this HOE, HRE is very small and they are negligible. So, in approximation model, we have taken this one, HRE and HOE, these are very, very small. How this is small means we have seen earlier while doing the approximation analysis, this HRE and HOE is very small. Okay, so we have replaced the value of HRE and HOE. We have by neglecting this one, we replaced the circuit. Okay, so this HRE into which this is a replace. This is very negligible, and this is also very negligible. So that's why we have neglected this one. We have shorted this one. Okay, we have taken this one. Okay, now by after neglecting this HRE and HOE, we can redraw the circuit. Okay, after removing the HRE and HOE from the hybrid model of this previous circuit, we have redrawn the circuit by remaining other parameters as it is. So this is the approximation model actually. Actually, this is the exact model. Then we have to go with this approximation model by considering the emitter resistance. Okay, and this is the current direction, or this is the base current, and this is the collector current, and this is the emitter current. Okay, accordingly, we will get the different parameters of this particular amplifier. Okay, have you understand the circuit?
Yes, sir.
Up to this, okay. Then we are going to neglect this HOE and HRE because of these are very small while taking the approximation model. While taking the approximation model, we have neglected this HRE and HOE, and earlier analysis we have seen how with these are very, very small as compared with the other parameters. That's why we have neglected this HRE and this HOE, and then we have redrawn the circuit after neglecting that those parameters like HRE and HOE, HRE and HOE. Okay, now this is the approximation model. Now we are going to determine the input impedance, output impedance, voltage gain and current gain. Okay, now what is the actually what do you mean by input impedance? Input impedance is nothing but the input voltage by input current. So if you consider this circuit, what is the input voltage? VI is the input voltage and IB is the input current. VI is the input voltage. Okay, VI is the input voltage and IB is the input current. Okay, now if you find the value of VI and IB, then you will get ZI. Zi is nothing but input impedance or Ri, whatever it may be, no problem. So input impedance or input resistance, simply Vi by Ib. Then we can get the value of Vi. So what do you mean by Vi? Vi is equal to, yeah, this is the, while measuring the value of Vi is equal to Ib into Hie plus, yeah, Hie plus 1 plus Hf into Re. Yeah, 1 plus Hf into this Re. Okay. Of course, we have seen earlier to measure the, yeah, Vi approximation analysis of C amplifier. Yeah, this is VB. We termed it as a VB. This while taking the common IB into HIE plus 1 plus HF into RL. RL means RC, or whatever, load resistance or load. Okay, so this is the equation for input voltage. Okay, earlier we mentioned the same we have taken here. So IB, actually IB into HIE plus 1 plus HF into RE into IB actually. So by taking the IB as a common, this will becomes like this, IB as a common, then HIE plus 1 plus HFP into RE by what is the input current? This is the IB is the input current, and this IB will get cancelled. Then the value of input impedance HI is equal to 1 plus ZI is equal to HIE plus 1 plus HF into RE. This is the input impedance. Okay, so input impedance up to this one. So here we didn't consider the source voltage and source resistance. Source voltage, source resistance, and this biasing resistance. So we have replaced the parallel combination of this R1 and R2 by RB. So R1 and R2 is parallel with, R1 is parallel with R2. We can redraw this these two resistance as a single resistance with the combination of parallel combination of these two. This is denoted by RB. Then we are going to find the ZI dash input impedance with source. Okay, this is the input impedance of your amplifier circuit. So transistor-sized hybrid model. Then we have to include the source voltage and source resistance, and this is denoted by ZI dash. Okay, now we'll get the ZI dash is equal to HI is parallel with yeah, this HI is parallel with this RB. HI is parallel with RB. Now we have obtained the value of this this one, where RB is equal to R1 parallel with R2. We'll get like this. So this is ZI dash. Of course, it is sufficient to us. ZI is sufficient to us. We have to calculate the input impedance. Input impedance is for understanding purpose. I have calculated the ZI dash also. So ZI dash is not necessary. You may perform this ZI. Then output impedance. Output impedance is nothing but it is reciprocal of the admittance. The admittance is nothing but it is a current by voltage. Actually, resistance is voltage by current, and admittance is the reciprocal of the impedance. Then admittance is equal to current by voltage. The output admittance can be obtained by removing the load. Actually, you have removed the load means this RC. Okay, we are going to remove the load RC. Is approximately we make this RC is infinite, and it is short circuit with input source Vs at this condition of I naught is equal to 0. Now we'll get the value of output admittance is equal to I naught is equal to 0. 0 by anything will be equal to 0. Then Z naught is equal to infinite. Of course, we have seen earlier in the approximation model of the C amplifier, the same we have get here while considering the emitter resistance into account. So Z naught is equal to infinite for approximation model in earlier case and this case also. Okay, yeah. Current gain is nothing but the output current by input current. Output current is a load current, and this is output current is a load current. It is opposite direction to the collector current. So this is both are in opposite in direction. This IL and IC. Okay, IL and IC are in opposite direction. So then okay, IL by IB is the our current gain, but IL is replaced with the minus IC. Minus indicates the negative direction. Yeah, that's what I am written here. The value of A is equal to IL by II. Okay, then IC minus IC by IA. Again, this is you can get the value of IC by IB into IB by II, IB by II. So we have multiplied and divided with this IB. Then this IC by IB is nothing but HFE. Okay, and this is nothing IB by this IB by I1 is nothing but IB by I1 is nothing but this one. HI is parallel with RB. HI is parallel with RB, or simply not parallel with RB. So this is by using this voltage division rule. So RB by RB plus HI, RB plus HI or ZI simply. Okay, this is the current gain. Simply voltage gain. Voltage gain is nothing but the output ratio of the output voltage by input voltage. Output voltage here, this is the output voltage. We'll get IL into RC is the output voltage. Input voltage is VI. So then we are going to get the value of voltage gain. We have find the value of VI in the case of input impedance. While measuring the input impedance, this is the value of VI, and then V naught is equal to IC by RC, and we have replaced the value of IC nothing but HFE into IB. See, if you IC, this is the current. They both are same. This is the current going through like this, like this, like this. This is the this HFE into IB same as with this IC. Okay, and we have replaced the value of IC by HFE into IB. Then we'll get like this. So this there is a IB in numerator and IB in denominator also. So this IB get cancelled. This minus as it is, then H minus of HFE minus of HFE HFE into RC by HIE plus 1 plus HFE into RE. So this is the formula for voltage gain. This is the formula for voltage gain. Okay. So these are the four formulas for analysis of the C amplifier with the emitter resistance. So simply you take the common emitter configuration amplifier with emitter resistor, and then you draw the AC equivalent. After that, hybrid equivalent model. Then get the approximation model. Now, by using this approximation model, we are going to derive the expression for the input impedance, output impedance, current gain, and voltage gain. So, input impedance is nothing but HIE plus 1 plus HFE into RE. Output impedance is infinite. Current gain is minus HFE into RB by RB plus ZI. And this voltage gain is minus HFE into RC by HIE plus 1 plus HFE into RE. So this is these are the values for C amplifier with emitter resistance. C amplifier with emitter resistor. Okay. Now the analysis of the C amplifier with analysis of the CC amplifier with emitter resistance. So this is simply called as the emitter follower. So why it is called as the emitter follower means we are going to obtain the output voltage across the emitter terminal. That's why it is called as the emitter follower. So emitter follower means we are going to give the input between the base and collector. We are going to get the measure the output between emitter and collector. Here collector is the common terminal for this one. Okay, this is the simple common collector amplifier circuit with emitter resistance. Then we are going to redraw the circuit by making this capacitor short and this VCC is short. Okay, then we are going to take this VCC short and capacitors are short. We can redraw the circuit. So by keeping the VS, RS, and then this CB is shorted, and this is R1, R2 is R1 and R2 are parallel. Then we can draw this. We can draw this circuit as a single resistor. That is R1 is parallel with R2. R1 is parallel with R2. Okay. Then we have keep transistor as it is. Then we are going to find the output voltage. Here the collector terminal is common for input and output. Yeah, this collector is grounded simply. So we are measuring. Take input is given between the base and collector. The output is taken between the emitter and the collector. Output is taken in between the emitter and the collector. Okay, emitter and the collector. So the CC amplifier is simply called as the emitter follower. Okay. So this is the simplified hybrid model for the common collector amplifier. Now we are going to replace the transistor, and next step we are going to replace the transistor with its equivalent hybrid model. Okay, the transistor is replaced with the equivalent hybrid model. Yeah, this is the equivalent hybrid model. Okay, so this is HIE, and of course we directly have drawn the approximation model. So while drawing the exact model, we were having the four parameters like HRE, HIE, HOE, HFE. But sorry for the interruption. Okay, yeah. Have you understand this one, all of you?
Yes, sir.
Okay. Uh, take this C amplifier circuit and then redraw the circuit according to our steps. So we have started with the complete circuit diagram of the CC amplifier. This is the complete circuit diagram of the CC amplifier. After that, uh, after that we assume all the capacitors are large because of these are considered to be a short circuit, such a way that we have shorted these capacitors like the CB and the CC. We have shorted here, and then we have replaced the DC power supply. Okay, we have also shorted the DC power supply. We have shorted the DC power supply. Simply we have grounded, and then after that we have replaced the transistor by with hybrid. This is the up to second step, and third step we have replaced the transistor with this hybrid model. So we have here we have taken the approximation model, not exact model. If it is exact model, there is a HR into VCE, and this there is a HOE. Okay, and these are very small as compared with these parameters. We have neglected this HRE and this HOE, so we can redraw this one. We have considered the RE as it is. Okay, then this is the hybrid parameter model of the common collector approximation hybrid parameter model. It is not exact. Okay, so this is the approximation hybrid parameter model. Okay, now solve for the input impedance, output impedance, current gain and voltage gain with the circuit. Please do yourself. Then I will explain. Anyone can obtain the parameters like input impedance, output impedance, current gain and voltage gain with this circuit. Please perform the analysis. Later I will explain. Okay. Hello. Anybody can respond, please. Okay, please do the analysis by using the circuit while by obtaining or determining the parameters like input impedance, output impedance, voltage gain and current gain with the circuit. Okay.
Okay, sir.
Then I will explain. What of course we have performed the so many analysis. So initially we have gone through the exact analysis, after that approximation analysis, and after that by considering the emitter resistance into account. Emitter resistance into account. Okay, you should be familiar with this analysis because of this is the one of the important. Okay. Uh, of course you do. Then I'll explain. So simply this is the I think you are familiar with the construction of the CC amplifier. Am I correct? So this is the construction of the CC amplifier. Uh, Here the collector is made common between the input and output terminal. That's why it is called as the CC. Okay, the collector is made common for both input and output terminal. So that's why it is called as the common collector amplifier. So the output is taken across the emitter. Okay, the output is taken across the emitter terminal, and that's why it is also known as a emitter follower. The construction is very simple. And this amplifier circuit, the collector base junction acts as input, but collector base junction acts as input, and emitter collector emitter junction acts as a output. Collector emitter junction as a, but usually in other amplifiers, emitter terminal is the input side and collector terminal is at the output side in case of the CB and CC. Whereas this is the special amplifier. This is the special amplifier. So that's why it is called as the emitter follower. Emitter follower. So why it is called as emitter follower means the output taken across the emitter, it exactly follow the input voltage variation. So because of if there is a variation at the input side, the emitter exactly follows the variation voltage. The variation depends. The output is depends upon the value of the variation of the input. Okay, this is exactly follows the variation in the input. So that's why it is called as the emitter follower. Emitter follower. Am I clear? Anybody, please respond.
Yes, sir.
Okay, so this is the somewhat different than the previous amplifier circuit like CE and CB. Here we are going to take the input and input junction between input junction between collector. Here collector is the common. Collector is made common between the input and output terminal. So the output is taken across the emitter. So that's why it is called as emitter follower. Okay, the collector base junction acts as an input. Collector base junction acts as an input, and collector emitter junction acts as an output. But usually the other amplifiers, the emitter is emitter terminal is the input side actually. But here the emitter terminal is output side. Okay, emitter terminal is at output side. In case of the common base, also it is a emitter terminal input side, and common collector, common emitter also it is emitter terminal is at input side. But here the emitter is at the output side. Okay, and another important thing is the output is taken across the emitter. Okay, and the emitter exactly follow the input voltage variation. If there is a variation in the input voltage, that variation the emitter terminal will follow the variation exactly what we have varied in there the input side. That variation is followed by the emitter. That's why it is called as the emitter follower. Emitter follower. Okay. So here there is an we have to connect one load resistance while measuring here. Okay, you have to connect one load resistance RL to be there, and then there is an RE, and these are the capacitors used for the coupling and blocking. So this is the blocking capacitor, and this is the coupling capacitor. We are going to provide the biasing by using this R1 and R2. R1 and R2 are used to provide the potential divider biasing or simply voltage divider biasing. This voltage divider biasing, the circuit employs the biasing by using this R1 and R2. Okay, this is the simple construction. Okay, now we are going to redraw the bits equivalent hybrid model by using these steps. So what simple steps? What are those simple steps? Means you have to assume the capacitors are large, so that's why we have shorted, and also we have replaced the DC power supply by short circuit, and then we are going to replace the transistor with the hybrid equivalent model. After that we will get the exact model, and then we have to neglect HRE and HOE because these are very negligible. Then you will get approximation model. This is the approximation model, and this is the hybrid model for the common collector amplifier. Approximation hybrid parameter model of a common collector amplifier. This is. Now we are going to find the input resistance. Input resistance is nothing but the input voltage by input current, and this is the input voltage and this is the current. Of course, it is similar to the C amplifier. This is similar to the C amplifier. HI into 1 plus HFE into RE. So what we have got in case of the CE amplifier, the same thing we have obtained here in case of the CC amplifier also. Of course, the Z dash this is the same with the similar with the CE. Now current gain is nothing but output current by input current. So again this is the it is more or less similar with the CE. Okay, this is the circuit current gain circuit. Okay, this is the equivalent circuit to find the current gain. This is the A is nothing but the output current by input current. Output current is the emitter current actually. So in case of the C amplifier, output current is the collector current, but here the output current is the emitter current, and the input current is the base. And there is an input current. This input current is nothing but divided into base current and another way this biasing current. So this is we have divided and multiplied by this IB. This IE by II is divided and multiplied by IB. This IE by IB is nothing but this one. 1 plus IE is equal to 1 plus HF into IB, then IB, then this IB by IA. So the value of 1 plus this IB get cancelled. We will get 1 plus HFE. Then this IB by IA is equal to this one. So RB by RB plus ZI. RB plus ZI. Okay. Similarly, voltage gain. So we'll get the voltage gain. This is the formula for voltage gain. Voltage gain is nothing but the output voltage by input voltage. Then output voltage is V0 and input voltage is equal to Vi. Yeah. If you go through this one, This is the output voltage. We are going to measure across the emitter resistance, and this is the value of VI, input voltage. Now we are going to find the input to output voltage and input voltage. Output voltage is equal to IE into RE by this VI. VI is have already calculated in C and CB, C and CC also, the same as with the previous one. VI is equal to IB into HIE plus 1 plus HF into RE. Yeah, this is now replace the value of IE. IE is equal to 1 plus HF into IB. Okay. Then there is IB at numerator and IB at denominator. This IB will get cancelled. What is the numerator? 1 plus HF into RE. 1 plus HF into RE. By in denominator HIE plus 1 plus HF into RE. HIE plus 1 plus HF into RE. Now we are going to add and subtract HIE. Add and subtract HIE to the numerator. We are going to add HIE and subtract HIE. So by adding HIE, if you take this one, HIE plus 1 plus HF into RE, and then HIE plus 1 plus HF into RE. So this one and this one will becomes 1. Okay, 1 minus HIE by 1 plus HIE plus 1 plus HF into RE. Okay, if it is very greater than this is very greater than with HIE, then the HF is very greater than 1. So then this will become HIE by HF into 1. If it is very greater than 1, if we add or subtract 1 from this HIE, there is not that much of change will be occur. So okay, I can write this 1 plus HFE as a HFE. Then this is RE. I have neglected this one. So because of this one, so finally AB is equal to this one. Output impedance. Output impedance is nothing but the output voltage by output current. Okay, output voltage by output current. Short circuit current to the output terminal, open circuit. Actually, this is the admittance actually. Current by voltage. Then now you can get this is the value of okay. So these are the parameters. Which we have obtained for the CC amplifier. Okay. You go through these all derivations and calculations. These are very important. So you remember these steps while drawing the hybrid equivalent model. You have to remember these steps. So draw the actual circuit diagram. So we will start with the complete circuit diagram of our amplifier. After that, we are going to replace the capacitors by short circuit, and we are also replace the DC source by the short circuit. Or in other words, we can say the DC VCC should be ground lines connected to the ground line. And also, we have to make the mark the points base, collector, and emitter with hybrid equivalent model, and replace the transistor with hybrid model. Then, if you want to perform the exact analysis, you have to consider all the 4 parameters: HIE, HRE, HFE, and HOE. If you want to perform the approximation analysis, this HRE and HOE are negligible. Okay, you have to consider the HRE and HOE as a negligible, so that you can redraw the circuit for approximation model, and then calculate all the parameters. So simply remember, gain is nothing but the output parameter by input current. Output parameter by input parameter. If it is a voltage gain, then output voltage by input voltage. If it is a current gain, output current by input current. Okay. Similarly, impedance. Impedance is nothing but the ratio of the voltage to current. Okay. If you want to measure the input impedance, you have to take the input voltage and input current. If you want to measure the output impedance, you have to take the output voltage and output current. Similarly, sometimes it is directly, it is not possible to measure the directly impedance. Then go with the admittance by taking the current by voltage. So we can get all the parameters. Okay, so with this we completed the analysis of all the configurations of CE, CB, CC configuration with exact model, approximation model, and with emitter resistance considering to the account. Emitter resistance is considering to the account. And we have remaining two topics are left. Two topics means FET as a VVR and FET analysis. Okay, JFET we are going. So like a transistor, we are going to analyze the FET by using only one, not all three. Actually, there is a three configurations in FET also: common source, common drain, and common gate. But we are going to perform the only common source analysis by taking the common source. Of course, like a CE in our transistor amplifier, the common source is the most commonly used configuration in the FET amplifier configuration. Okay, so that we are going to see the next class FET FET as a VVR. After that, small signal model of a FET. So next class we'll discuss about these two. Prior to that, to prove one important theorem, that is nothing but the Miller's theorem. So what is a Miller's theorem? What it indicates? What is the importance of the Miller theorem? So then there is a proof for the Miller theorem. So we'll go through the Miller theorem. So prior to that, I request you all please perform this analysis. I'll provide the notes up to this emitter follower. Today I'll post the material up to emitter follower. So there are two topics are left. One is Miller's theorem, and other one is the FET analysis. FET analysis. FET as a voltage variable resistor, and FET analysis. So only common source configuration. Common source configuration. Okay. Up to this, we have seen the classification of amplifier, then different region of operations, and then transistor voltage specifications for the various operating ranges, and biasing. Of course, we have studied in earlier semester, and then these are the simple amplifier configurations for the CG, CB, CC. After that, how the transistor will act as an amplifier, and then hybrid model representation. Okay, so this is the hybrid model representation. After that, we have drawn the small signal equivalent by using Thevenin's equivalent and Norton's equivalent. Okay, this is the method. We have seen the method for drawing the small signal equivalent circuit. After that, I've seen some how we are going to express the input voltage and output current as a function of input current and output voltage. Okay, here there are dependent variables and independent variables. Okay, dependent variables are the input voltage and output current. Independent variables are input current and output voltage. So by choosing the independent values, and we are going to calculate the value of dependent variables. So we can express these variables in the equation form like this. Okay, we can rewrite, and we can have defined the hybrid parameters. What do you mean by H11, H12, H121, and H22? Okay, and these all obtained from this equation only. Okay, these are all obtained from this equation only. Why I keep I, R, F, and O means actually H11 is nothing but the ratio of the input voltage by input current. As we know, the input voltage and in ratio of input voltage to input current is nothing but the impedance or resistance. Because of we have taken the input parameters, that's why it is called as the input impedance or input resistance. That's why this H parameter is termed as a HI. I stands for input. Similarly, HR. R is nothing but actually V. This is V naught actually. Yes, last time I told that this is nothing but the Vi by V naught. This is by taking the Ia is equal to 0. Vi by V naught, not I naught. Okay, actually the ratio of output voltage by input voltage is the gain, but this is the ratio of the input voltage by output voltage. This is not I naught, this is V naught. Replace this I naught as a V naught. Then that's why it is called as the reverse voltage gain. Reverse voltage gain. Actually, V naught by VI is the voltage gain, but we have VI by V naught actually. So 1 by this one is equal to the voltage gain. That's why it is called as the reverse voltage transfer gain. This is denoted by R. This is the current gain. Current gain as it is I naught by II. This is that's why simply we can say it is a current gain or forward current gain. Forward means direct current gain. Or this is a output current by input voltage. Actually, voltage by current is the impedance. So this is nothing but the reciprocal of this impedance. That is nothing, we call it as an admittance. So both are in both are output parameters. That's why it is called as the HO. This is the definition of the hybrid parameters. We have saw the analysis by taking this equation and we have redrawn the circuit. And these are the hybrid model for the different configurations. Okay, please go through this model. Okay, these are the exact model actually. Okay, so these are the advantages and benefits with the hybrid model parameters. It's the hybrid parameter model for the CE amplifier. Just I have taken the simple CE amplifier. Okay, without taking the R1 and R2, these are all okay. Simply I have taken on the input parameter. Then I have taken this one, and then these are the values. Now I have analyzed this transistor amplifier using hybrid model. Okay, so in this amplifier circuit, I have taken the source voltage, source resistance, and load resistance taken into the account, and then this is the hybrid equivalent model, and we have gone through these all parameters by using the different formulas. CB different configuration, not different formula. CB, CE, CC configuration, and we have seen the comparison. Conversion formulas for hybrid parameters. After that, characteristics of each type of amplifier. Common emitter, what are the characteristics of the common emitter and common base and common collector? What are the applications with the common emitter, common base and common collector? We have gone through this one. After that, we have compared the transistor amplifier configurations with its typical values. Okay, what is the voltage gain, current gain, input impedance or output impedance of the different configurations? Okay, yeah. These are the steps to analyze the amplifier circuit, transistor amplifier circuit. So this is the way to draw this one. Then now we are going to simplified hybrid model or approximation hybrid model. Okay, so these are all for an exact analysis. We have taken one common circuit. With that one, we have determined all the parameters. So this is the while determining the input impedance. So we have determined the input impedance for one configuration. The same can be obtained by using this one only. Okay, that's why I have completed the three. Then I have gone through the simplified hybrid model. This is the approximation model. Approximation model for the CE, CB, and CC. After that, I have considered hybrid emitter resistance into account. I have considered the emitter resistance into account. Then we have seen the analysis like this. Okay, up to this, I have completed one part, and another part is PET analysis. And then prior to that, we'll go through some Millers theorem. What is a Millers theorem and what it says? Okay, and why we go with this Millers theorem? Is there any importance with the Millers theorem or not? Okay, and how it is, how the Millers theorem helps while analyzing the amplifier circuit. Okay, what is the statement of the Millers theorem and how we are going to actually Millers theorem is nothing but it actually states that the impedance connected between the input and output can be split into two impedances actually. Okay, so that's the statement here. We are going to connect one impedance which is connected between the input and output. This is the input voltage and this is the output voltage. We are going to connect one impedance between the input and output voltage. that is splitted into two impedances. One impedance is this one Z1 and other impedance is Z2. So one impedance is given by Z by 1 minus K, and other impedance is nothing but Z into K by K minus 1, Z into K by K minus 1. So this is the input one. So the single impedance Z can be splitted into two impedances. The single impedance which is connected between terminal 1 and terminal input terminal and output terminal. So this is splitted into two inputs, two impedances at input end and output end. Okay, individual impedances at the input end and output end. So input end, this is the impedance. Z1 is the input impedance. The Z1 is nothing but Z by 1 minus K, and Z2 is the impedance at the output end. So this is given by Z into K by K minus 1. Okay, then what is K? K is nothing but one constant. K is nothing but one constant. This constant is given by the ratio of V1, V2 by V1. This is simply we can say it is a gain actually. The K is nothing but V2 by V1. V2 by V1 is a K. So by taking the value of V2 by V1 as a K, then we are going to get, if we connect an impedance between the input and output terminal, then this is splitted into two impedances at the input end and the output end. Okay, so these are the input impedance. So we are going to prove the value of Z1 and Z2. As we know the value of I. So what is the value of I and what is the value of I is nothing but this. How can get the value of I1 and I2? So accordingly, we will get the value of. We know the value of K is a constant. K is nothing but the V2 by V1. So from that, I have to assume this one. K is nothing but the V2 by V1. V2 is the output voltage and V1 is the input voltage. So from this, we can say that V2 is equal to K into V1. So then we'll get this one. Okay. Yeah. This is the Z1 and similarly Z2. Next class we'll discuss about this Miller theorem. After that, we go to the FET analysis. FET, how the FET will be acts as a voltage variable resistor, and then what is the small signal model of the FET. But in case of the FET, we are going to see the small signal model of the FET by using the common source configuration only. We'll stick to only one configuration. Why? Because in our syllabus, it is we have to do. We have to study about this. Yeah, small signal model of FET, especially for common source, common one particular, not more than that. Okay. Yeah. With this, I am going to stop. Next class, we will discuss about the Miller theorem and FET analysis. FET as a BVR and FET analysis. Okay. So within 1 or 2 classes, so we'll come to the end of the second unit. After that, we'll go through some problems. Okay, we're going to solve some examples for this small signal amplifiers or single stage amplifiers, not small, for the single stage amplifiers. After that, we'll move to the next topic, multi-stage. So with this, I'm going to stop. Okay. Okay. Thank you. Thank you all for your patience listening. Vasu.
Yes, sir.
Close chestano. Can I stop my sharing?
Okay, sir.